Okay, let's start off with a story about a physics demo. So suppose I take a ball and I shoot one ball horizontally with some initial velocity, and then the other ball I take from the same height and I drop it. And the question is, which one hits the ground first? And the answer is, in the absence of air resistance, they hit the ground at the same time, and it's a really cool demo. And in fact, there was a great show, Mythbusters show, where they did this with an actual pistol rifle, not a little, what's the handheld gun? Handgun. and they got that to work. It was they actually shot the bullet and then dropped the bullet over here, so they landed near each other, and it pretty much worked. It was pretty impressive. But should it work with significant air drag? So if there's no air drag, then I have the downward force on this one and the downward force on that one is the same. The x and y motions are independent, so they start with the same initial y velocity, the same with the initial y position, the same y acceleration. Everything's the same, so they hit the ground at the same time. What if I have linear drag? So now let's say I have this, I shoot this one ball this way. Let's say it starts off that way with some initial velocity v0, and then there's this mg, and then there'd be fd. I'm calling this the drag force, negative bv. It looks just like that. I've already shown in my previous video that you can break this into x and y motions, and they do not impact each other. So let's say I have a ball that's falling, and it's going like, it's shot at an angle, it's going this way, so it has that force, and then it has this upward F drag and back. That's V. So F dy equals negative B Vy. I showed that before in the previous video. Now if I take another ball and just drop it, and it has the same vertical velocity, it's going to have the same upward component. It's going to be the same. So if the ball has linear drag, then even this will still work. Okay, this one will have, both have no air drag in the vertical case when you shoot them, and as they both fall, they'll both increase the same amount of air drag, and they'll end up being the same. The end. What if I have this kind of air drag? So this is quadratic air drag. Actually, we usually write this as, that's a negative 1/2 rho a c v squared v hat. So this is the density of air, that's a cross-sectional area of the object, and that's a drag coefficient that depends on the shape. So in this case, I have to square the velocity and then use the unit vector here. So let's say I have that same situation, but now I have air resistance going back this way. So let's draw this vector. F d is, I'll call this as just negative c. Now I have to find the square of the velocity, so that's going to be equal to vx squared plus vy squared, square rooted, then squared again, so I can just leave it like that. And then the unit vector is going to be equal to vx, vy, 0, I'm going to have 0 z motion, divided by vx squared plus vy squared to the 1/2. That's going to give me the unit vector. You have to put that in there. You can't just ignore that. It's still a force. So if I include these two, I get negative c times vx squared plus vy squared to the 1/2 times the velocity, vx, vy, 0. So now if I just want the y velocity, the y motion, I get this. F net y is going to be equal to this, negative c vx squared plus vy squared to the 1/2 times vy minus mg equals dvy dt. And that's a problem, because you see it has a component of the velocity in the x direction in the y equation. So if I take two balls that have the same vertical velocity, so they're both moving down a little bit, this one's going down and this one's going down with the same vertical velocity, they will not have the same vertical drag force. This one will have more because the velocity depends on, the the air drag depends on the x and the y velocity. So quadratic air resistance, this problem doesn't work. And in fact, this problem is super, super, super difficult. In fact, I don't think you can do it to solve this analytically because you're going to get two coupled differential equations that both have Vx and Vy in them, and so that's really tough. You can do this numerically though. Okay, so that's the story of the Mythbusters. You should go watch that episode somewhere and why they hit the ground at the same time.